Hi dear children, in today's video, I'll teach you one detailed answer from lesson 2 current electricity. Okay ma? Listen ma, you can definitely expect one detailed answer from this lesson for your physics exam. Children, to view the notes and answers in your screen, you have to increase the picture quality. For that, you can see three dots at the right top of your screen. Touch it and then select quality. Then a drop down list appears. From that, you have to select advanced. Then you have to increase the picture quality to 720p or 1080p. Okay ma? Today, let's learn second detailed answer, okay? That is macroscopic form of Ohm's law. I'll tell you the question now. Obtain the macroscopic form of Ohm's law from its microscopic form and then discuss its limitation, okay? Now, let's enter into the topic. Macroscopic model of Ohm's law, okay? And this macroscopic model of Ohm's law, we have to derive it from the microscopic model of Ohm's law. The Ohm's law can be derived from the equation J is equal to sigma E. And we know that the microscopic model of Ohm's law is J is equal to sigma E vector, right? In the previous video, we have discussed about it. That is first detail, microscopic model of Ohm's law. If you haven't seen that video, I'll give you the link in the description box. You can refer that video too. Okay ma? Yeah. Now we know the microscopic model of Ohm's law. Microscopic model of Ohm's law formula என்னன்னா J is equal to sigma E vector. இப்போ இந்த microscopic model of Ohm's law இருந்து we have to derive the macroscopic model of Ohm's law. Okay ma? For this, we have to consider a segment of wire. நம்ம ஒரு wire consider பண்ணணும். அந்த wireோட length வந்து L and the cross sectional area is A. Okay. Look at the diagram now. We have to consider a wire with length L and cross sectional area A. Okay. Then when a potential difference V is applied across the wire, a net electric field is created in the wire which constitutes the current. அதில் அந்த ஒயரில் வந்து நம்ம ஒரு பொட்டன்ஷியல் டிஃப்ரென்ஸ் அப்ளை பண்ணும்போது என்ன ஆகும், எலக்ட்ரிக் ஃபீல்டு வந்து ஜென்ரேட் ஆகும். ஓகேவா? அந்த எலக்ட்ரிக் ஃபீல்டு தான் நத்திங் பட் இ வெக்டர். ஓகே, and this E vector it constitutes the current. Electric field இருக்கும்போது அதில் கரண்ட்டும் இருக்கும். Current is nothing but I. It is denoted in the diagram. Look it carefully now. Okay, so I'll tell you once again, diagramல என்னெல்லாம் details நம்ம பார்க்கணும்னா, we have to consider a segment of wire. அந்த wireோட length வந்து L and அந்த wireோட area of cross section that is A. Then when we apply potential difference across the wire, then net electric field is created. அந்த electric field தான் E vector. ஓகேவா? B is nothing but potential difference. இந்த B apply பண்ணும்போது electric field generate ஆகும். That electric field is E vector. In the presence of electric field, there will be current and that current is denoted as capital I. Okay ma? So diagramலேருந்து இவ்வளோ details தான் we have to describe it. Okay. Okay, then we have to assume that the electric field is uniform in the entire length of the wire. Then நம்ம என்ன பண்ணணும்னா, just நம்ம வந்து ஒரு assumption பண்ணணும். என்னன்னா, இந்த electric field வந்து it is uniform throughout the entire length of the wire. இப்படி யூனிஃபார்மாக இருந்துன்னா, then the potential difference voltage in voltage, okay, இந்த potential difference வந்து we can write it as V is equal to E into L. V is equal to E into L. Let us consider this as equation number 2. First law, the Ohm's law can be derived from equation J is equal to sigma E vector. அது என்னன்னா microscopic model, right? அந்த microscopic model நம்ம equation 1 எடுத்திருக்கோம். Then second equation என்னது? V is equal to E into L. That is equation number 2. இப்போ இந்த equation number 2லேருந்து we can find the formula for E. Equation number 2 implies EL is equal to V. நம்ம ஒன்றுமே பண்ணலை, ஜஸ்ட் சைடை மட்டும் சேஞ்ச் பண்ணி எழுதியிருக்கோம். ஓகே, லெஃப்ட் ஹேண்ட் சைடில் இருக்க டேர்ம் ரைட்டில் எழுதியிருக்கோம், ரைட்டில் இருக்க டேர்ம் லெஃப்ட் ஹேண்ட் சைடில் எழுதியிருக்கோம். தென் EL is equal to V. ஸோ இதுலேருந்து E மட்டும் we need it, right? We need the value of E. So we have to take E at left side and the remaining terms to the right side. ஸோ இந்த L ரைட் சைடில் போகும்போது அது வந்து டிவைடட் ஃபார்மில் வரும். ஸோ V divided by L, it comes to the denominator. From this equation number 2, we know that E is equal to V divided by L. Then we can consider the value of E, that is V divided by L, as equation number 3. As we know, the magnitude of current density formula என்னது? J is equal to sigma into E. இன்னி என்ன பண்ணணும்னா J is equal to sigma into E. இதை வந்து equation number 4 consider பண்ணலாம். Then from this, in this equation number 4, we have to substitute the value of E. Okay, in the equation number 4 we have to substitute the value of E from equation number 3. So E ka place la வந்து we have to replace it by V divided by L. அப்ப J is equal to என்ன ஆகும்? J is equal to sigma into V divided by L. Then you see here, but J is equal to I by A. Either we can consider it as next equation number 7. So write the equation as I by A is equal to sigma into V by L. So இது எப்படி வந்துன்னா, we have to substitute equation number 7 in equation number 5. Okay, while substituting the value of J is equal to I by A in equation number 5, அந்த J க்கு placeல I by A போடணும். That's all. Okay, so I by A is equal to sigma into V divided by L. இது next equation we can consider it, that is equation number 8. Then by rearranging the above equation we get, இதை வந்து rearrange பண்ணணும். Rearranging எப்படி பண்ணணும்னா, நமக்கு V மட்டும் ஒரு சைடில் இருக்கணும் and the remaining terms should go to the next side. So we can keep this V in the left hand side, and when all the remaining terms comes to the next side, the equation becomes V is equal to I into L divided by sigma A. Now from this equation, the quantity L divided by sigma A is called as resistance of the conductor. Okay, L divided by sigma A na, it is nothing but the resistance of the conductor, and it is denoted as capital R. Okay ma, note that the resistance is directly proportional to the length of the conductor and inversely proportional to the area of cross section. இந்த resistance எப்படி இருக்கும்னா, lengthக்கு directly proportional இருக்கும், then area of cross section க்கு inversely proportional இருக்கும். Okay, and therefore the macroscopic form of Ohm's law can be stated as V is equal to I into R. Nothing but equation number 9 ல அந்த L divided by sigma A வந்து நம்ம resistance capital R substitute பண்ணியிருக்கோம். So therefore we have to replace that term, that is that L divided by sigma A as capital R. அப்படி பண்ணும்போது therefore the macroscopic form of Ohm's law can be stated as V is equal to I into R. And consider this as next equation, that is equation number 10. Okay ma? This is the answer for derive the macroscopic form of Ohm's law from microscopic form. Then its limitation is also asked in the same detail answer. So after this we have to write the limitations too. Okay ma? So now from this equation number 10, that is V is equal to I into R, we can derive the equation, we can derive the expression for R. Okay, so from the above equation, the resistance is the ratio of potential difference across the given conductor to the current passing through the conductor. So potential difference is denoted by capital V and current is denoted as capital I. So R is equal to V divided by I. Okay ma? So from this above equation, the resistance is the ratio of potential difference across the given conductor to the current passing through the conductor. So R is equal to V divided by capital I. And the unit of resistance is ohm, OHM, or it is denoted by this symbol. Okay. Then from equation number 10, we infer that the graph between the current versus voltage is a straight line with a slope equal to the inverse of the resistance R of the conductor. Okay, then this is shown in the figure. Now we look at the diagram, you can understand that. First diagram, it denotes the current against voltage for a conductor which obeys Ohm's law, and in the second diagram it denotes the current against voltage for a non-ohmic device. Dear children, do you know the difference between ohmic and non-ohmic device? Now I'll tell you the difference between ohmic and non-ohmic devices. Ohmic device. First let's see what is ohmic device. The materials for which the current against the voltage graph is a straight line through the origin are said to obey Ohm's law and their behavior is said to be ohmic. Okay. The materials, if the materials obeys Ohm's law, then they are said to be ohmic devices. Then the materials or devices that do not follow Ohm's law are said to be non-ohmic devices. And these non-ohmic devices have more complex relationship between voltage and current. A plot of current I against potential difference V for a non-ohmic material is non-linear and they do not have a constant resistance. So for non-ohmic device, the plot of I against V is non-linear, whereas in ohmic device the plot of I against V is linear, that is a straight slanting line. Hope this section was useful for you and meet you soon in the next video.